Hello everyone. So in the previous video, so that is in design linked list. So part one, we discussed how to create the node class, so constructor and linked list constructor. So adding at head and at tail next of all at particular index. Okay. So we are left over with deleting at particular index and next of all get method. Let me finish first of all deletion operation and finally I'll explain the get method. Okay. So here already it's given, right? Okay. Indexes are starting from zero here. Okay. We should consider as zero indexed here. So zero, one, two, three. I taken the indexes here for the linked list. Okay. So first of all, we should focus on the base condition here. So what is the size of this linked list here? It's 4, right? Okay. Next. So if I suppose if index is less than 0, if index is negative value, okay. So actually this is the method, guys, okay. So observe, delete at index, okay. Some index value passed, okay. That's it. Only index value passed to the method. We need to delete that index value node here, okay. So for suppose if index value is negative, okay, if it is -1 or else the -2, is it possible to perform the deletion? No, right? Okay. So this is the base condition. If index value, if it is less than 0 or else, okay. For suppose if index value is matching with the size, okay. For suppose index value is 4 or else if it is 5. So do we have indexes 4 and 5 here? We have indexes up to 3, right? Okay. So these are indexes, guys. So if index passed as size, so or else if it is crossing the size, okay, so then it's not possible to perform the deletion operation, right? So this is the another base condition here. If for suppose index is greater than or is equals to of size, so you can observe one change here. If index is equivalent to the size, it's possible to perform insertion. Okay, you observed in the add at particular index. Okay, but here deletion is not possible if index is matching with the size. Okay, I hope you understood. Okay, so here for suppose let us take this one index is 0. Okay, if index is 0, so we need to delete value present in the 0th index, right? Okay, delete the node which is present in 0 index. So that is nothing but deleting node at beginning. Okay, so deleting at node beginning means simply we should update this head address to the next of head. Okay, and updating head to the next of head. Okay, so what happens here simply, so it starts traversing from here. So this unused resources is going to be collected by the gap base, okay, gap base collector. Or else you can do one thing. So the another way is initially we should take this one head address into set temp. Afterwards we should update head to the next of head node, and finally temp on assigning to the none, it is going to be deleted the beginning node. Okay. But this is not required, so just have knowledge on this, okay? So another way of deletion. So now this is if index is 0, okay? For suppose if index is 2, okay? So that is the middle node, how we can delete this, okay? So means here on deleting this node 2, what has to be happened? So 20 next has to be connected to the 40, right? Okay. So here in order to make connections like this, we need references here. Okay, so do this node have any reference here? No. Okay, if reference are not there, it's not possible to perform any operation. Okay, in linked list, you know this. So now we need to get the reference here. Okay, so how we are going to get reference means you can observe the adding node at particular index. Okay, there also we perform the same operation. Here also we'll do the same thing. Initially, head address will take it into the temporary variable, okay, and count I'll take it as listen guys, count I'll take it as 1 because we need to stop at the before index itself. Okay, if index is 2 means we need to stop at index 1. Okay, so that we can make so the connections here. Okay, so that's why I'm starting count from 1 here. Says we'll check whether count and index are matching or not. Okay, not matching. If not matches, so temp simply we should update to the next node. So while updating, so count we should increment to the increment so by 1. Okay, now if you check, so the count value and index value are matching. Okay, so if matches, so we need to stop it. Okay, simple one step, with one step we can so perform the deletion operation, guys. Okay, so whatever the temp next connection you are observing, we should make it to the temp next of next. See, listen, what I am saying here is temp next connection. So we should make it to temp. Sorry, we should make it to temp next of next. Okay, so tell me what is temp next here. It's 30, right? Okay, what is 30 next? It's nothing but so 40. So what is going to be happened? So to the 20 next, so finally, so 40 is going to be connected. As usual, unused resources are going to be collected so by the garbage collector. Okay, so here with the help of this expression, what is going to be happened, guys? Okay, so 20 next is going to be connected to this. Okay, so 1 minute, 20 next is going to be connected to this, and so this connection is going to be break here. Okay, so simple. With like this, we can so perform deletion node at some particular index here. Okay, and don't forget so to reduce size. Okay, by the time of performing decrement. Okay, so size we need to reduce to the 3 here. Okay, so now we have only the 3 nodes, and this one comes. This one changes as index number 2 because already index number 2 deleted here. Okay, so I hope you understood this. So let us implement this one now. So have a look, everyone. If first let us focus on base condition, guys. Okay, our index we already got it. It's not required to return anything. Simply we should delete it. So or else if index is greater than or is equals to of so size. Okay, so then what you need to do, simply we should return control back. Okay, so or else if index is pointing to the 0, here you can observe deleting node at beginning also. In this same method, you can observe the two operations here. Actually, add operations you observed at so beginning and next of all, so at ending and next of all, so at middle. So, but here deletion operations you are going to observe in the beginning and at particular index middle. Okay. So simply what I said, the head address we should update to the so the head next. Okay, so that we can remove the first node here. For suppose if not, if index is not 0, okay, so we need to get the reference to the previous node here. Okay, for that sake, so we need to traverse up to that but before index. Okay, for traversing up to the before index, that's why I'm taking count here, and initially so the head address we should collect into the temp variable here. Okay, and so until count not equivalent of so the index here. Okay, similar to this you are going to observe now. So what you need to do, so temp we should update to the next location here, and at the same time we should update so the count by 1. Okay, finally after completion of the loop, means when our count and index matches. Okay, we got reference to the previous node to where the node has to be deleted. Okay, so now we can so make one connection here. So temp next on making so the connection to the next of next. So the current node is going to be deleted here. Okay. Irrespective of if else, so one operation has to be performed. That is size we need to decrement so by 1 here. Okay. So this is a deleting node at particular index. Okay. With this you observe the uh, deleting so the beginning node also. Okay. So fine, we are left over with only one method now. So that is called a get method. Let us complete. We need to return the value which are present at that particular index. If for suppose, so you observe this. If index is invalid, we need to return -1. We need to focus on the base conditions also here. Okay. So let us take so the picture now. Observe everyone. So here, for suppose once again, if index is less than, so this is zero index, first index, and second index, guys. Okay. Uh, what is so size here? It's 3. And so for suppose if index value is negative, okay, -1 or else -2, it's not possible, right? Okay. So this is one so condition here. If index is less than 0, we need to return -1. So or else, okay, not and or. Well, suppose if index is matching with the size or else if it is crossing, so the size, is it possible to retrieve the value here? Same thing, whatever you observed in the delete at particular index, same base conditions we'll take here. For deletion and get method, we take so the same base condition here, okay? Index, if it is greater than or is equals to size, we are going to return so -1, okay? So fine, I hope so it's clear base condition for everyone. Now, for suppose if any other so thing passed here, okay? What I need to do, let us check now. This is the base condition. Okay, yeah, fine. Now let us take, so we need to get the index value, so 2, okay? Whatever the value which is present in the index 2, we need to return it, okay? So what we'll do, similar. In the added particular index, deleted particular index, you observed, right? Count variable, we need to take like that. But now we need to take, so the count variable to 0 because we need to traverse up to the node to where we have to be returned, okay? So the index 2 node value we have to return, right? For inserting, so we should traverse up to the before node. For deleting, so we should traverse up to the before node. But for performing, so accessing operation, we should traverse up to the index node. Okay, that's why count we should take to 0, and so initially head address we should collect in temp. So we check whether so the count and index are matching or not here. Okay, it's not matching. If not matches, yes, temp we update to the next location and count. So we perform increment. Okay, count we increment by 1. So again, so count and index are not matching. So again, so what we'll do, temp will update to the next location. Okay, so count we increment by 1. Now so the index and count are matching. Okay, so we can return so the node, so the temporary node value, so that is called 30. Okay, so this is the process. Okay, so base conditions and next of all, so the program guys. Okay, let us complete this one now. First, for suppose if index is less than 0 or else if index is greater than or is equals to, so size, so simply we should return -1. There actually we returned control back, okay? So we didn't perform anything. Actually, we should not return anything here, okay? We should return so the none. That's why we take and simply return, okay? But here now, so we should take this next. So observe what is the next step? Initially, we should collect so the head address into the temp and count. We should start from 0 here, okay? And next, so until count so is not equivalent to index, okay? We should keep on repeat this procedure. That is the temp. We should update to the next location. See, say many times you observe this. That's why you feel very easy, okay? Same thing you are going to observe in the linked list programs. When compared to remaining, so it's easy, guys. Okay, count we should so update. Final, whenever so count and index value matches, loop ends, right? Okay, in that scenario, control comes outside. We need to return so the whatever the data holding by the temp variable here. Okay, so temp dot data. So that particular node data we need to return here. This is accessing method from the beginning. Accessing middle node, so already I done another video, so gone through that. Accessing node from the ending and deleting node from the ending, so you just gone through, or else within short span of time I'll make so the video regarding that. Okay, so fine. Let us check whether so it works or not. Let us run and submit. Yeah, we got wrong answer here. For what? It's a get method. Okay, so what is the problem here? Let us check now. 1 minute. might be deleting. So 1 minute. We we should take so delete this one. If index is 0, so we are pausing. So head we are updating, right? Irrespective of this, we need. So here we didn't perform so size increment. Observe here in add at index method. So we didn't performed size increment. So while if index is 0, we pass it control to the so added head, their size is going to be incremented. So if index is somewhere else, so we need to increment so size by 1 here. Okay. So fine, that is a problem here regarding so that so we are getting problem in the remain cases here. Okay. I hope you understood. Now let us submit here. Let us check. Fine. So did you mean added head here? Okay. So fine. You have one more error. It's there. So wait one more minute. So I think so we got so another error here. Let me so check that error. Okay. So wait for 1 minute, guys. Everyone. Added head. So fine. Added tail. Let us check added tail. Next, let us check. So added particular index here. So let us check 1 minute. So what is the error we are getting? So here, linked list object has no attribute added head. Okay, fine. See, here we have so the added head. So A uppercase and next of all H uppercase, right? Okay. So fine here. So I taken H in lowercase. That is the error we are getting. So here, let us submit once again now. So check everyone. Yeah, fine. So all test cases get passed here. Okay. So I hope you understood this one. So gone through both these videos, part 1 and part 2. Okay. Don't leave in it. So let us meet in the next video. So thank you everyone.